Okay, so what we want to do today was talk about the polarization of information on the web. And so, next slide. What we wanted to do was look at the objective and impact. We wanted to see and measure the different polarization of opinions, information, and different users on the web. And the goal and the reason why we were looking at this is because we wanted to look at the polarization of information, you know, based upon the political climate in the United States. We wanted to see how different users were interacting and viewing and had viewpoints on certain issues. And then the goal is getting a clear understanding of how these users were interacting, the stuff that they believed in, the things that they were communicating about, could hopefully bridge the gap between these different groups and help facilitate different discourse between these different groups of people. So for the approach, what we wanted to do is we looked at Twitter data. We wanted to create a completely directed connected graph where each of the tweets represented nodes. And then we wanted to have edge weights that corresponded to the connections between each of the nodes. So that corresponded to the transition probabilities between the different tweets. So how similar are the tweets to each other? And how similar, given one tweet, are you likely to agree with another tweet? So then after we created our graph, then we wanted to cluster our graph. So we wanted to be able to identify clear communities of thought. And so then after that, what we did is then we measured the difference between each of the clusters so that then, therefore, we could take out the different polarization of different ideas that existed on Twitter. So we got our data from two different sources. So we got our data from dataworld.com. It was really great to have these pre-clean data sets for our use. We found one of the data sets we used was called Progressive Issues Sentiment. And so that was dealing with 4 different progressive topics: abortion, atheism, Hillary Clinton, and feminism. And then the data source had each of the outcomes saying you're either for it, against it, or neutral. And then we also had another source, which was politician tweets. And the politician tweets consisted of a database of 1.6 million different tweets from politicians, encompassing 700 different politicians. And then we wanted to compare the hashtags that different politicians were using. So to calculate the weight, so the data set came to us with these sentiment scores computed for us, measuring how strongly for or against the person was for each topic. And so what we did is they were given a range of 0 to 1. So what we did is for the against tweets, we multiplied those values by -1. So then we had a range from -1 being that you were totally, completely against the thing, and then being 1, you were absolutely for it. And so then the edge weights were computed based upon the distance between those two tweets and then normalized on a scale from 0 to 1. And so then the weight calculations for the political hashtags, what we did is for each pair of politicians that existed, we calculated how many hashtags each of the two politicians had in common. And then we compared all the politician scores, and then we normalized on a scale from 0 to 1 per politician.
So let's take a look at our results. The first topic was atheism, and that was given to us in the data set. So what we see here is each star in our graph corresponds to a different clustering that our algorithm identified. At first, we get a very fine-grained clustering. We get 9 groups of thought out of the roughly 150 to 200 tweets we were looking at. And it converges these groups until we reach one large group, the entire graph that we built. The most interesting cluster that we found was the one with the lowest conductance. What the conductance measure is we felt as a very natural way to measure the polarization. Basically what we look at is the number or the total weight of edges leaving the cluster and compare that to the total weight of the edges within the cluster. So higher conductance corresponds to lower polarization. We see more agreement between the two groups of thought. Next slide, please. The next topic was the feminist movement. We see similar scores when the algorithm identified the two groups of thought. We see about 0.5. And just as a sanity check, we also had the potential to come up with the simple clustering of just for and against that was given to us in the data set, and that directly matched what the algorithm was telling us, so that was good news. Next one was Hillary Clinton, similar scores. Next one, please. And then the legalization of abortion, similar scores. Now, the reason we think we're getting the same scores for each of the topics is because the data set was trying to equally represent both groups of thought. So what I would like to try and do is actually get an unbiased sample from Twitter, and that might reveal more polarization and differences between topics. Next slide. Now the politician hashtags, so this was an interesting data set. There was, like she said, roughly 1 million hashtags, 1 million tweets and 700 politicians. At first we used all the hashtags, and what we saw was very low polarization. We were suspicious, so what we did was removed the 25% most common hashtags, try to get rid of some noise, and this is what we found. With filtered hashtags, it revealed some more polarization. We got a mean conductance of about 0.8, the lowest conductance, and that is when the algorithm identified about 5 groups of thought.
So let's do the demo of one of the data sets that we use. So this is a visualization of the atheism data set, where we use this is for the mean lowest conductance score value, so where we have like 3 huge clusters and then one tiny cluster, which our algorithm just couldn't find like where they exactly belong. So if you hover over it, so this is a 3D graph, so you can just like play around with it. So if you hover around it, each node is a tweet, so you can read the tweet of the person. So so each of this cluster is fully connected, so that means there's a node between each of these nodes, and each of this cluster has a representative node that we use to connect it to a cluster of a node of a different cluster. We could have it fully connected, but since it would be very messy, we just use one representative node from each cluster to connect it to a node of different clusters. So we can just look over the hashtags of each of the cluster and see they are fairly similar. And we can go here and look at this, and so on. And you can also zoom in, and then just look at all of it like individually. So
maybe we can hold questions for the very end. That way
yeah.
That's okay.
Yes. And so we want to continue working on this. The data visualization and everything, our data set looks really cool. So what we want to do later is like we want to make a publicly available web app where anybody can go there and like search for a trending topic or any topic that you want to choose, and then see how the public's opinion about that topic is at the current moment. So you can see how the polarization of each topic is, or like how the public sentiment is about that topic. So for that, we also want to improve our algorithm. We want to make sure we have a better way of calculating how we do edge weights and everything like that. So for that, we need a lot of money from you guys, probably some $1 million or something, right? So so that we can continue work on this, and anybody who wants to look at this data can easily benefit from this. So like we talked about before, these were the 2 data sources that we used, Figure8.com and Data Vault. So last but not the least, we want to thank all of the wonderful people here at the center who helped us make this week really wonderful. All the TAs, Dr. Ward, and everybody, Kelly, and Dr. Ladd, who helped us. So thank you so much. So if you have questions.
Thank you, guys. That was excellent. So I'll use this microphone to come around if for anyone who has questions, and then you can do that. So we'll start here because I saw you.
Yeah, I got very excited about the visualization. What program did you use?
We used Python, and there's a library called Plotly. We use that for this. So it's actually not that-
Plotly, Plotly.
So yeah, this is all the code that I wrote though.
Yeah.
For all this data visualization. So
Awesome,
yeah,
thank you.
it's called Plotly in Python.
Thank you. Any other questions for Team A? You guys. So just how polarized are we?
So what we came up with is So what we came up with is actually a way to kind of compare topics. Until we get more data, until we analyze more topics, I think it's going to be tough to say if we just look at one number. Okay, 0.5 conductance. We don't really have anything to compare that to. So once we see more topics, we can kind of put it on a scale.
Yeah.
Mm-hmm.
That sounds great.
Can I take the mic too?
Yeah.
Yeah, one of the other things that we wanted to do was look at the politicians were really interesting because analyzing all the tweets is actually, they tweet about more things in common than you might think.
That's what I was seeing on your graph. Yeah.
Yeah, it's because when we were looking at that, there's a lot of tweets that people may have, like, oh, happy hashtag 4th of July and stuff that may have more that are potentially in common. So I think, one of the future works that we want to do is obviously we saw more polarization once we took away all those common tweets and looked at, more the subtext of what people were tweeting about. We use 75% because, then you sort of break down into different groups, based on percentiles, took away the top 25% most popular ones. And then also what we want to do in future work, but the data set was limiting in the time of span that we had, was we wanted to look at the different inter-issue similarities. So, the goal is that we want to be able to query a user and see what they're saying about, say, atheism and abortion, and see how those polarization topics.
There's interactions happening there. Yeah.
Right, exactly.
Cool. Excellent work. Thank you so much. Let's give these guys a hand. I appreciate that. Okay.